Assalamualaikum and hi everyone. How are you? Hope you are in a good health. So today we are going to learn about nuclear physics, particularly about nuclear energy. Before further lesson, let's look at the learning outcome first. So for today's lesson, students should be able to describe generation of electrical energy in nuclear reactor. In this learning outcome, we are going to focus on the purpose of nuclear reactor, basic element of nuclear reactor, chain reaction in nuclear reactor, the ways to control energy produced from chain reaction in nuclear reactor, and the working of the nuclear reactor. Okay, for your information that in Malaysia, electricity is generated using the sources like the coal and water. However, the countries like United States, Japan, France, India, and China have been using the nuclear energy to generate the electrical energy in their countries. So if I show you these two pictures, what can you guess from today's lesson? You can pause this video and think by your own. So I'm pretty sure that all of you will know that the first picture is about the nuclear fission reaction that we learned from previous class. While this picture is actually a nuclear power plant station, and have you ever heard and know it before? And what is the connection between the nuclear fission reaction and nuclear power plant station? Actually, nuclear power plant is a thermal power station. It consists of nuclear reactor, where in this nuclear reactor, the nuclear fission reaction takes place in order to generate the electrical energy. So this is an example of nuclear power plant station, which it consists numerous of buildings and facilities. So the main buildings in this power plant station is first the turbine buildings, where it houses several turbines as well as generators necessary for electrical power generation. So next is containment building, where the nuclear reactor is placed. And inside this containment building, the nuclear reaction takes place where water is heated up. The last one is the cooling tower, which used to cool down the hot water. So for this lesson, we're going to focus on the containment building, which consists of nuclear reactor, to learn on how it can generate the electrical energy. This is a containment building as you see just now. So inside this containment building, this is a nuclear reactor, or we call it as a core reactor, where there is a nuclear fission take place inside it. Then this is a turbine which will rotate the generator to produce the electricity to houses and buildings. So this picture is an overview for you to know where is the nuclear reactor was located. So next is the purpose of nuclear reactor. So as I mentioned you just now that the nuclear reactor consists of a nuclear fission process. So it used to initiate nuclear fission reaction, to control the rate of nuclear fission reaction, and to extract the energy produced by the fission reaction. And now we're going to look at the basic element in nuclear reactor. As you can see in this figure, this is the charge tube, this is control rod, radiation shielding, pressure vessels, this is a moderator, and the last one is the fuel rod. So the three core components in the nuclear reactor that we are going to learn is control rod, moderator, and fuel rods. So actually, as you can imagine, these control rods and fuel rods are arranged like this, as you can see in this figure, where there are 4 control rods and many of fuel rods. And inside this fuel rod, it consists of radioactive material which is uranium, or we call it as a uranium fuel pellet, as shown in this figure. So this is why the nuclear fission reaction can occur inside the nuclear reactor. Now we're gonna look at nuclear fission process of uranium inside a nuclear reactor, or we call it as a chain reaction. As you can see in this picture, this is the place on where the nuclear fission reaction of uranium take place in nuclear reactor. So actually, in a nuclear reactor, the fission of uranium-235 nucleus produce 2 daughter nuclei and 3 fast-moving neutrons with large amount of energy release. This neutron will bombard with other uranium nuclei and it will release more neutrons through continuous nuclear fission. So this chain reaction will continuously occur in the nuclear reactor. And this continuous reaction needs to be controlled so that it not produce excess number of neutrons. So how we can control the energy produced during the chain reaction? So don't worry, I will explain it to you. As mentioned before, that the fuel rods which contain the uranium-235 are normally immersed in water, and that water is actually act as a moderator inside the nuclear reactor. So as you can see in this video, the thermal neutron which have energy about 0.04 electron volt will produce a fission reaction with uranium-235, and this neutron have the energy about 1 MeV. This new neutron which have high energy with them may escape and produce another fission process, as you can see in this figure, and they have a capability to produce another fission reaction. So here's the moderator comes into play, where the moderators have a capability to slow down the speed of this high energy neutron. So usually, ordinary or heavy water is used as a moderator, where the water molecule in the moderator useful in slowing down the higher energy neutron which leave the fuel elements after the nuclear fission. So this high energy neutron collide with water molecule, as you can see, then it will lose some energy with every collision and therefore become slowing down. We need a steady flow of energy from the reactor, so the control rod were used to control the speed of the reaction inside the reactor that can cause any further unnecessary fission reaction, because we know that every single fission reaction leaves excess neutron which then are utilized for more subsequent fission reactions, as you can see in this figure. So the control rods can control the number of neutrons produced by absorbing the excess neutron in the moderator. Usually, these control rods are made up of boron or cadmium. Then, as you can see in this video, a steady output of energy can be maintained by inserting or removing the control rods in the nuclear reactor. Okay, so now we have understood how the components or the core components in the nuclear reactor used to control the energy produced from the nuclear fission reaction of uranium. So next, let's understand the working of nuclear reactor briefly on how it can generate electrical energy as overall. So there is a huge amount of heat released during the fission reaction of uranium-235, which make the water that acts as a moderator inside the core reactor become heated. So this heated water in the core reactor flows into the heat exchanger through the metallic pipes. So the metallic pipes conduct heat from the heated water of core reactor that make the water in heat exchanger also get heated up and change to steam at very high pressure. So the steam, which then used to rotate the turbine, in turn to drive the generator to produce the electricity. So actually, the water, which is the moderator inside the core reactor, is a radioactive, so it cannot leave the containment building. So water is continuously flow in and out of nuclear reactor using the pump. So this is how nuclear reactors successfully generate nuclear energy from fission reaction to generate the electricity. So this is the nuclear reactor containment where there is a nuclear fission reaction of uranium take place. And this is actually the fuel rod inside that nuclear reactor. For better visualization of nuclear reactor, so I have a short video for you to watch in a few seconds so that you can know how the real core reactor looks like. Actually, this nuclear reactor is not for generate electricity, but it's just used for research and also experiment only. So this is actually the control rod, and this is the fuel rods that contain the radioactive material. So before we end our lesson, let's answer some questions to test your understanding. So the first question is, state 3 core components in nuclear reactor. So the answer is moderator, control rods, and fuel rod, because the keyword is 3 core components. Second question is, explain how to control the energy produced during the chain reaction in nuclear reactor, which is the chain reaction of the uranium. So the answer is using the control rod. Because the control rod can control the excess number of neutrons produced that can cause unnecessary fission reaction. And also use the moderator to slow down the energy of the neutron that can maintain the chain reaction. Then the last question is, describe generation of electrical energy in nuclear reactor. You can pause this video for a while to answer it. So actually, the answer is that there is a huge amount of heat released during the fission reaction of uranium-235 in the nuclear reactor. So it will make the water inside the core reactor become heated, and that heated water enter the heat exchanger through a series of pipes. So the water inside the heat exchanger become heated up and change to steam at very high pressure. So that steam will be used to rotate the turbine and then drive the generator to produce electricity. And actually the water is continuously flow in and out of nuclear reactor using the pump because that water is radioactive, so it cannot leave the containment building. So that's all for today's lesson. Till we meet again for the next lesson. Thank you everyone. Stay safe and bye.